Jai Hind to everyone. So right now I am a Gaurav Srivastava, assistant professor in electrical and electronics department from Ajay Kumar Garg Engineering College. So today we have discussed about the fuel cell, which is related to our renewable energy resources. That is the subject related to final year open elective, and the subject code is KOE 074. So basically this topic is correlated to the unit 4, but we have no that a fuel cell, it is a very important non-conventional energy resources. So here we can say the renewable energy sources. So in every day, time to time, the life is increasing and the energy resources will be decreasing. Population and the electricity requirement day by day increasing. So we have shifted from our conventional source to the non-conventional sources, so that they can available time to time and for the long time. So in this we have discussed about the what is the fuel cell, their introduction, their working, how this fuel cell will be working on. Then we can say the merits, what is the different merits of this fuel cell and demerits, because whenever we discuss about any conventional sources like hydro or the geothermal resources or the solar cell or the fuel cell, so we have discussed about their merits as well as the demerits, and then we have to move, you can say, the types, or you can say the classification of the fuel cell. So there are different type of classification or the types is available, like alucon fuel cells, direct methanol cells, phosphoric acid fuel cells, proton, polymer exchange membrane fuel cells, molten carbonate fuel cells. So there is a 5 type of classification which we included in our this presentation. So that is what is a fuel cell, like how we can generate the electricity from the fuel cell. So basically this is the energy conversion of the electrochemical cell. Like we have changed the chemical energy into a electrical energy without any conventional or you can the sources is available. So fuel cell is an electrochemical cell that converts the chemical energy of a fuel, or you can say the of an hydrogen and an oxidizing agent, because whenever we go for the reaction, chemical reaction, so we require the oxidizing availability. So these equations can be converted or generated through the electricity through a pair of the redox reaction. Okay, like we have conducted we have utilized the taken of your oxygen or the hydrogen and there is some oxidizing agent. So what will be conducted here? So like this, hydrogen is inserted and the oxygen is, what will the combination is generated? The water is generated and the electrons will be generated as a fuel. So these electrons can be converted to the electricity. So that's why we have using the fuel cell as a hydrogen or the oxygen with the compare develop the water as well as the electrons and as well as the heat. So that is a reaction diagram of this fuel cell. As well as fuel cells are different from most batteries in a requirement sources of the fuel, and the oxygen usually from air to sustain the chemical reaction. So whereas the battery chemical energy utilized comes from the metals and their ions, so they are commonly already present in the batteries. So except in the flow batteries, so fuel can produce electricity continuously as long as the fuel and oxygen are supplied to the cell. So like what is a fuel cell? We can take an examples of hydrogen atoms, like in this we can say that is a proton exchange membrane and that is the electrical side. What is moving? There is a hydrogen, from the hydrogen ions can be moved from the tank, and there is a oxygen from the air. So these hydrogens and the oxygens are inbuilt together to form a water molecule H2O, and there is the electrons can be generated. So these electrons can be moving through this electrical circuit. So this is generated to the electricity, you can say. So here we can say that aapka catalyst we have provided as a cathode, as a anode, and proton exchange membrane we can use. So hydrogen atoms enters the fuel cell at the anode, where a chemical reaction steps from the ionized, and these hydrogen atoms are ionized and carry a positive electrical charge, and the negatively charged electrons provide the current through a wires to do the work. So If an alternating current AC is needed, what is the DC output of the fuel cell must be routed through a conversion device called an inverter. So oxygen enters the fuel cell at the cathode, and some cell types like the electrons above combines with the electrons returning from the electron circuit, and the hydrogen ion that travel through the electrolyte from the anode. In other cell types, what will happen? The oxygen picks up the electrons and travels through the electrolyte to the anode, where it combines with the hydrogen ion. So we can say directly that is the electron plays a key role in the fuel cell. It must permit only the appropriate ions to pass between the anode and cathode, and these free electrons or the other substances could travel through the electrolyte. What will happen? They will disturb the chemical reaction. So whether they combined at anode or cathode together, hydrogen and oxygen form water, which again form the cell. So as long as fuel cell is supplied with the hydrogen and oxygen, it will generate the electricity. So we can say we want a continuous supply of the hydrogen as well as the oxygen. So here that is the operation equation. Like what will happen at the anode terminals, hydrogen is baked into hydrogen ions as well as the 4 electron ions, and at cathode side we can say this oxygen, what will the supplied here, plus 4 electrons which is generated from the anode, and the hydrogen ions can convert it to the hydrogen water molecules. So these electrons which will generate the electricity, we can say. So this is the operation of the fuel cell. We can summarize here. At the anode, hydrogen gas is ionized, which is producing free electrons and the hydrogen ions, and these hydrogen ions is using the oxygen and generated the water molecule as well as the electrons for the electricity production. So that is the major working of the any fuel cell. So different types of fuel cell we can select on the basis of anode, cathode, as well as the what is are using the exchange membrane. Right now we have moved the merits, because whenever we studies about any renewable resources like geothermal resources and the hydro, or you can say the wind energy, ocean thermal, fuel cell. So every equipment, every technology has some advantages as the disadvantages. So here we can discuss about the merits of the fuel cell. So it has a very high efficiency as high as 70%. Since it is a direct conversion process, it does not involve a thermal process. Because whenever we move or compare to any efficiency process, like whatever the energy generation process, so we compare to the thermal process, in which we can say that their thermal plant efficiency ranges between 30 to 50 mostly. So but in terms of fuel cell, we directly generate the electricity through the chemical without actually using the thermo and with higher efficiency. So the use of fuel cells have less mechanical components, because like whenever we move the wind energy, solar energy, geothermal, so there is a conventional process or the mechanical components also required. So if these components are increasing, whatever the result is, their maintenance cost is increases, their efficiency is reduces. But in the case of fuel cell, we don't require any mechanical component, or you can say a very less component, and it is a direct energy process, so that we have the high efficiency as well as the low maintenance. Fuel cells take little time to start operation. Like thermal power plant, we have taken a very different type of cells, or you can say section, like boiler unit, turbines unit, coal handling plant. but in the fuel cell very less time, so it will start easily. Space as compared to the generation power capacity, so we have required a very less space for the setup. Large amount of cooling water is not required like in a conventional steam power plant. Definitely that is a very important advantages. In case of the thermal power plant, what will happen? We required a large high capacity of the water for the cooling purpose, but in the that is because conventional steam power plant. But in the case of non-conventional power plant or in the fuel cell, we have a very less. Fuel cell can be installed near the use point. Near the use point, where we have to require this power, and the same location that can be developed. But in the case of conventional, what will happen? We have set up a very far distance about the requirement of the electricity. So that's why transmission cost increases. But in the case of fuel cell, we just required or set up on the required locations. They do not make noiseless, hence they can be used in the residential areas as well. So that is some merits related to the fuel cell. Now we have to move to their demerits. So when we go for the merits as well as the demerits, what will happen? Like we have considered about low service life. Like conventional plant, we have taken as a 20 to 30, 40 years, as well as the hydrothermal plant 30 to 50 years their service life. But in the case of fuel cell, life is very limited. High initial cost, definitely because of the large capacity requirement for the electricity, we have required high initial cost for the investment of the different fuel cells which are using. We have required to continuous supply of the hydrogen as well as the oxygen for generation of the electricity. Electronfication. The use of fuel cell power is still unsafe due to explosive nature of the hydrogen or definitely. So that is a major, you can say, the disadvantage or the limitations. Okay, there is the explosion charges is very high. Whenever we have various studies or news get about the explosion of the batteries. So batteries is again same as the chemical reaction. So here we have generated the fuel electricity through the fuel cell. So definitely there is a chances of the explosive nature. So it is still unsafe. Availability of suitable auto catalyst to the function efficiency for the long duration has also restricted for the commercial application. So we don't use as a commercial application. The refilling of auto vehicles is quite difficult in the case of fuel cell. So that is the limitations, or you can say the demerits of the fuel cell. Right now we have moved to the classification. Classification, that means types of. So types of depends on whatever the oxidant we are using or the more electrolyte. So here we can say the fuel cell technologies can be classified in many ways. The classification based on fuel and oxidation combination, based on electrolyte, direct fuel or indirect fuel, temperature basis, power ratings, and the application. So there is a 6 classification of the fuel cell available, but mostly we have divided into their electrolyte. So the most common classification is used as a electrolyte. So like whatever the we have taken the electrolyte classification. So here we can use the electrolyte as a alkaline, direct methanol, phosphoric acid, proton polymer exchange membrane, molten carbonate fuel cell, solid oxide, zinc air, regenerative, reversible. So there is a 9 types of classification is available. Based on electrolyte. So by one we have studied about individual fuel cell. So like first we have gone to the alkaline fuel cell. So alkaline fuel cell, that means we have using the electrolyte as a alkaline. Alkaline fuel cells were one of the first fuel cell technologies which was developed, and they were the first type widely used in the US space program to produce electricity, electrical energy and water on the onboard spacecraft. So basically the fuel cell uses the solution of potassium hydroxide in water as the electrolyte and can use a variety of non-precious metal as a catalyst at the anode and the cathode. And recently we have used the alkaline fuel cell use a polymer membrane as the electrolyte having been developed. Operates and compressed hydrogen air and the oxygen. They generally used a solution of potassium hydroxide chemically QH in a water as the electrolyte. So here we can using the electrolyte as a QH, potassium hydroxide, and about their efficiency 70%, which is highly, you can say, the efficiency related to the electricity generation production, and their operating temperature is about 150 to 200 degrees Celsius. And their individual cell output ranges from 300 watts to the 5 kilowatt. So we don't use as a commercial. Through this cell, we can't use produce the energy through the for a commercial purpose. Alkali cells were used in Apollo spacecraft to provide both electricity and the drinking water to their. They require pure hydrogen fuel, however, and their platinum electrode cathodes are the expensive. And like any container filled with liquid, they can leak. So like here, we can say the reactions. So that is a alkali fuel cell. What will happen? There is again anode side, hydrogen, cathode, there is oxygen, and electrolyte. Was it the electrolyte? That is a hydroxyl ion, which are used as a KH. So here the oxygen, hydrogen is gone. What will happen? There is at the reaction is hydrogen plus 4 QH ions or hydroxyl ions through the electrolyte. They generate the water molecules and the electrons, and these electrons combine together at the cathode where they can generate the hydroxyl ion. So these chemical reaction process continuously and they generate the like water. So this water can be outside, and electrons that is moved through a circuit and generate the power. So that is the chemical reactions which are produced generated in the alkaline fuel cell. Alkaline fuel cell. So we have moved to the another fuel cell, that is the direct methanol. So here we can use the electrolyte as a direct methanol fuel cell. So they are powered by the pure methanol, which is usually mixed with water and fed directly to the fuel cell at the anode. Hydrogen, which can be fused directly fuel cell system by removing hydrogen fuels such as methanol, ethanol and the hydrocarbon fuels. Efficiencies of these approximates 40% at operating temperatures 50 to 120. Like alkaline, we have read about their efficiency 70%, their operating temperature to 150 to 200 degrees Celsius. But in the case of direct methanol cell, their efficiency is reducing up to 40%, as well as their operating temperature is 50 to 120. But they are again used as the provide power for portable fuel cell applications such as phones or the laptop, computer. Their batteries can be developed through the direct methanol fuel cell. So like in their equation, you can see here, so that is the anode, what will happen, and that is the cathode, and here we can use the electrolyte. So electrolyte में आपके hydrogen आ रहे हैं. So anode, what will the reaction is going on? Methanol plus hydrogen or water generated the carbon dioxide plus 6 hydrogen ions plus 6 electron ions. And these electron ions and the hydrogen ions combined together at the cathode with the oxygen, they generated the water molecules. So I have discussed about direct methanol cell, and the reaction is going on here, anode. At the anode side, methanol is combined together with the water molecules, and they generated the carbon dioxide plus hydrogen ions as well as the electron ions. And these hydrogen ions and the electron ions can combine together at the cathode side with the oxygen. They generated the water molecules. So overall we can say the combined equations like this: methanol plus 3/2 oxygens combined together carbon dioxide and the water molecules. So these are the correlation reactions, that is the total reaction that is circulated again and again, and the oxygen electron ion which are generated in this anode and the cathode side reactions together to generate electricity. But this main disadvantage of this cell is about their low operating oxidation of the methanol through hydrogen ions. So they have requires more active catalysts, which increasing the cost and the weight. Now third, that is a phosphoric acid fuel cell. So in the phosphoric acid fuel cell, we can say that is their efficiency about 40 to 80%, and their operating range is 150 to 200 degrees centigrade. So every fuel cell we can discuss about their efficiency, their temperature, their operating temperature, what will and their outputs, ki haan aap how much power you can generate it through this fuel cell. Like existing phosphoric acid cells having the outputs up to a 200 kilowatt and 11 megawatt units have been tested already with the phosphoric acid fuel cell. Carbon monoxide concentration of about 1.5%, which represents the choice of fuel they can use it. Gasoline is used, the sulfur must be removed. Platinum electrode catalysts are needed. So these are some specification or the requirement related to the phosphoric acid fuel cell. So like now the circuit, again what will happen at the anode side? We can take in the hydrogen, and the cathode side, that is the oxygen, and here as a electrolyte as a hydrogen ions which are generated. So these again equations can be generated, and the electron ions created through the electricity production as well as the water as the output. So like anode, we can say the hydrogen can be break into a hydrogen ion plus electrons, and this hydrogen ions and the electrons can be combined together with oxygen at the cathode, generated the water molecule. So overall we can say the total reactions becomes like this: oxygen plus hydrogen is equal to 2 water molecules. So I hope you can see the difference, not a major difference in any fuel cell, but they have some limitations related to their operating temperature, their efficiency, and their equations related to their electrolyte, whatever the electrolyte we can use in the particularly fuel cell. So if you have a knowledge about fuel cell, you can say and know name known as a electrolyte. So definitely you can explain and write up about any types of fuel cell, but you have to just some points related to whatever their capacity, their temperature, their efficiency and their electrolyte. So, if you have any 4 points, you have definitely described any fuel cell. Then next है आपका proton exchange membrane fuel cell. So, here we can use as a proton exchange membrane fuel cell work as a polymer electrolyte in the form of thin permeable sheets, and their efficiency is about 50%, 40 to 50%, and their operating temperature is 80 degrees centigrade. Their output range 52 to 50. So, there is just some find out like every fuel cell having their efficiency, their operating temperature, electrolyte, then their output, any other things. I think that is the 4 requirements related to any fuel cell. We can even, if you have these 4 data, you can easily explain and describe them, their working. The solid flexible membrane will not taken, so they have related to their particularly application, or you can say the part. So, that is the equations. Again, hydrogen at the anode, oxygen at the cathode, electrolytes, hydrogen sand, and their chemical reactions. There is a phosphoric acid as a fuel cell we can use. At anode side reactions, what is the anode side reactions? Again, hydrogens can be break into the hydrogen molecules plus electrons, and so that is the chemical reaction. What is the how is the electrons generated in this fuel cell? The hydrogen molecules, and this break into the hydrogen molecules plus electrons, and these hydrogen molecules and the electrons go to the cathode side with the reaction of the oxygen to generate the water molecules. So, that is the combined equations, we can say that. So, there is some advantage we can describe here, because this is a very important cell. So, like they have start rapidly, operating temperature is less than 100 degree, less expensive, longer life as compared to another fuel cell, generate more power for a given volume, that is a high power density we have with this. Now, next, that is the molten carbonate fuel cell. So, basically it uses the high temperature compounds of the salt like sodium or the magnesium carbonate, usually CO3 compound, as the electrolyte. Their efficiency range is 60 to 80%, and their operating temperature is about 650. So, high. So, that is the highest you can say the operating temperature range. As compared to the all fuel cell till now. Units output of the 2 megawatts available have been constructed, and design exists for units up to 100 megawatts. So, I suppose that is why their efficiency is high as well as the temperature is high, due to their large application, you can say the generation of the electricity. The high temperature limits damage from carbon monoxide poisoning of the cell, and waste heat can be recycled to make additional electricity. So, that is why their efficiency is high, because of they produce the additional electricity through their recycle process. Their nickel electrolyte catalysts are expensive compared to the platinum, but the high temperature also limits the materials, and they can be used safe use of the too hot for the home uses. So, now we have studies about the molten carbonate fuel cell, their equations. So, like at the anode side, So like at the anode side, what will happen? The hydrogen and the carbon dioxide, because we have the electrolyte here, combined together with the hydrogen gas, generated the water molecules as well as the carbon dioxide plus the electrons ion. And these carbon dioxide and the electron ions combined together with the oxygen at the anode cathode side, they have produced the electrolytes. And these electrons is the main reason for the electricity production or the electrons generation. So these electrons can move through the electron circuit here through the load and generated the electricity. So we can define the total reaction. Hydrogen plus hydrogen plus oxygen plus carbon dioxide generated the water molecules and the carbon dioxide. So that is the chemical reactions which is held in the molten carbonate fuel cell, because we have taken the carbonate as a electrolyte. So here we have studies about different type of fuel cell related to their electrolyte, which are using hydrogen and the oxygens are the same at the anode and the cathode, and they have producing the electrons, which are main reason, or you can say which have flown through the circuit to produce electricity. So that is all about the fuel cell and the classification. We have moved to the next chapter related to our new non-conventional resources. Thanks.